Hi, welcome back to Raja's tuition. So, everybody is doing well. Hope you're all good. So, today we are going to study about our beautiful science subject. Okay, so let's start our 9th CBSE. The chapter name is Matter in Our Surrounding. Okay, I'm here talking about all the notions about the chapter or all the principles of the chapter about the matter. Okay, so first of all, what do you know about the matter? Anyone knows? Yes, I think you all know about the matter, right? So actually, our body is completely made up of matter, right? Our body, which is made up of atom, we know the each basic unit of a life, which is made up of the cell. The matter consists of air, water, fire, like all those things we call as Panchabhuta or Panchavasta. Okay, so first of all, we know the definition of matter. What do you mean by the matter? Yeah, matter is anything which occupy the space and has definite mass it's also. Right, I will show you in the screen, right? So the definition of matter is anything which occupy the space and has definite mass too. So we know the definition of matter. Matter is anything which occupy the space and having definite mass. So that we call as matter. Okay, so let me do the classification of matter. So first we move on to the classification of matter. Okay, so you know that how we classify the matter? Yes, early Indian philosopher classified in the form of the 5 different form of matters. Actually, that include air, earth, fire, sky, and also water. That we call as the matter, or we call as the Panchatava, or we call Panchabhutam. Okay, so these are the 5 sense of Panchatavas or Panchabhuta in our matter sensations. Okay. So, on the basis of the physical state, the matter which we classified as the solid, that we know, right? Solid, liquid, and gases. Okay, these are the 3 physical state of matter that we classified under based of matter, that including solid, liquid, and of gases. Okay, so on the basis of the chemical composition, the matter is again classified under based on pure substance and also including the mixture. The 2 type based on the chemical compositions are pure substance and also by mixtures. Okay, so these are the 2 type of classification we studied. The first which is based on the physical classification, that include solid, liquid, and gas, and second is under based on the chemical composition of matter, which we classified as the pure substance and of the mixture. Again, these pure substance we classified based on the elements and compounds. The pure substance we again classified as elements and compound. Okay, so then the mixtures are again classified into, we know that we eat mixture, right? So in the mixture, there is always, we know that they're having homogeneous mixture and a heterogeneous mixture. So the mixture is again classified into homogeneous mixture and a heterogeneous mixture. So these are the classification we have to study in this chapter. Okay, next we move on to the physical nature of matter. So next what we studied? The matter which is based on the physical nature. Okay, actually the matter is made up of the particle that we know. So including this particles we know that it is very tiny. We can't see through our naked eye. It's actually the microscopic particles, right? So first the point is the physical particles, right? The particles of the matter which are too tiny in nature. Okay, so the particles of matter and have space in between them. Okay, so next the particles of matter which are continuously moving in them. And next thing, the particles of matter which always contact each other or we attract each other. So these are the 4 points belong to the physical nature of matter. So physical nature of matter consists of what are the 4 points including the The particles of matter which are too tiny, the particles of matter which are continuously moving, the particles of matter which always attracted together, and particles of matter which having all those things are combined into forming as we call as the matter. Okay, so next we move on to the experiments in our textbooks. Okay, shall we start? Okay, so first belong to the matter. It's a particles of matter which is very tiny. Take some water in the first beaker and note its level. Actually, note the level from this level. Okay, so dissolve some salt or sugar with the help of glass rod inside this beaker. Okay, first of all, take the beaker, add some water with the level, and next we add some sugar or salt in this beaker by using the glass rod. Okay, so the salt dissolve in water with the level of water which does not change, that we also know. Okay, so this is because the particles of matter which get into the space between the particles of water. So look the point, because the particles of water get into the space between the particles of the water. Okay, so this shows that the matter which is completely made up of the particles. So this experiment shows the three beaker. Okay, so next we move on to the yet another experiment which belongs to the matter. The next one is the particles of matter which are very tiny. Okay, this shows the experiment by means of we have to take 2 or 3 crystals of potassium permanganate which have to dissolve in the 100 ml of water. Okay, so dissolve in 100 ml of water in a beaker. Okay, then take the 10 ml of this potassium permanganate solution which is dissolved in that water. We have to take and add to the other 100 ml of water. Okay, so again take the 10 ml of from this beaker solution and again dissolve in the 100 ml of water and repeat this process in 5 or 6 times. Okay, then we can see that the very few crystals of the potassium permanganate can color to the means the large volume of water. So because the millions of particles in this particle which are very tiny in each of the crystals. Okay, this shows in the experiment. Clear? The third experiment which belongs to the matter is the particles of matter which have the space between them. Okay, so the activity as take some water in the beaker and note its level. Okay, take some water and put it in the beaker and note its level first thing. Okay, so next dissolve some salt or some sugar with the help of the glass rod. Okay, the salt which is dissolved in the water but its level of water doesn't change. We can see in the picture. Okay, so actually this is because the particles of the salt get into the space between the particles of the water. So this experiment shows by this way. Clear? Okay. It's a particle of matter which are continuously moving. This belongs to the matter experiment. Okay, I will show the picture here. So take some water in the beaker and put a drop of blue or red color which is or mean the ink color which is slowly along the sides of the beaker. You can see in the picture, right? So leave it undisturbed for the few hours. We can see the change through that beaker. Okay, so the ink spreads evenly throughout the water due to the movement of particles of water and within the ink too. Okay, so actually we know that the intermixing of 2 or more different types of matter on their own we call as diffusion. We studied it in the last grade as what we mean the diffusion. The diffusion means the particles can move from the higher concentration to the region of lower concentration. We call it as diffusion. Here also happened the same thing. It's mean called diffusion. So that's why here we call as the particles of matter which is continuously moving over the water or even any particles in there. So these are the 4 types of different experiments that we explained about the matter thing. Clear? Okay. So the last one is the one more experiment is here. The particles of matter which is always attract each other, that we know because I will show the experiment here. Look at the picture. Take an iron nail in there. Okay, and a piece of chalk and a rubber band. 3 things we needed, that the iron nail, a piece of chalk and a rubber band. Try breaking them by hammering, cutting or by means of stretching. You can choose either one. Okay, so it is more easier to break the chalk, less easier to break the rubber band, and it's more difficult to break the iron nail. We can feel and we know that. right? So here this is because the particles of in the iron nail which is held together with a great forces than that of rubber band or in the chalk. So that's why we call as the particles of matter is always attract each other. So that's a difference here shown by the three things by means of iron nail, chalk and of by means rubber band. So we know that the last experiment by means of the particles of matter is always attract each other. Clear? Okay. So next we move on to the our interesting topic in the matter, that's a three different states of matter. Okay, that we know and we studied in our 7th, 8th and of all the standards we know, and we also know by our general knowledge too, right? So what are the three things of matter? We know it's a solid, liquid and of gases. What are the three things included? Solid, liquid and gases. Solid, liquid and gases, these are the three different states of matter that we know. Okay, so you can see the picture here. I will describe all those things in the detail. Okay, so first of all, we know that matter is completely different in the three form of states. Okay, so first we know the solid, liquid and gases. So first of all, we introduce the properties of solids here. So here we can see the picture of solid and how the property of solid completely interdetermined with them. Okay, so we want to, you can see the picture here. The solids have the definite shape and having the fixed volume that we know. You can see the chair, you can hold the pen, you can hold the rubber. All these things are made up of solid and having the definite shape and having the fixed volume in them, right? So the space between the particle which always the minimum. There is no maximum space in between the solid. We can feel because if having the space between the solid is maximum, we can't say it's a solid, right? So that's why the space between the solid is always minimum in them. So the force of attraction between the particles which is always maximum in the solid. So that's why the name solid is always kept for the solid. So the moment of particle which is minimum there and they are least compressible. Can you hold the rubber? Your eraser is complete compressed. Can you hold the pen is compressible? No. So that's why they having the least compressible is called solid. So then the rate of diffusion which is very least for solid. Clear. So we learned the properties of solid. So next we move on to the properties of liquid here. Okay, we know the liquid, right? So liquids have, there is no definite shape in them, but having the fixed volume there. So if we hold the water in the beaker, we hold the bottle, it's having the shape of the bottle of beaker of liquid. Okay, so the liquid can shape of the container that we call. Clear. So the properties of liquids include the space between the liquid is always intermediate. Okay. So the force of attraction between the particles is always intermediate and the movement of the particle which is intermediate and having less compressible and the rate of diffusion which is more than that of the solid. You can see the picture here. Okay. So what are the points? We have to revise. So the liquids have no definite shape. If we carry the container, there is a shape of the liquid. Okay, so the space between the particles is intermediate and force of attraction between the particle is intermediate, the movement of the particle is intermediate and the less compressible liquids and the rate of diffusion which is more than that of the solid. So here it's all about the properties of liquids. You can see the picture here, you can understand well, clear? Okay, then the property of gases. So gases, the same as of liquid, there is no definite shape and having the fixed volume. Okay, so gas occupy the whole space of the container. Okay, so the space between the particles of gas which is always maximum in them, the force of between the particle which is always minimum in gases. Okay, so the movement of particle which is maximum in the gases than that of the solid and of the liquid. Okay, so they are most compressible than that of liquid and the solid. Okay, which is more compressible than its gases. Okay, so the rate of diffusion of more solids than that of the liquid. You can see the three variant pictures of solid, liquid and gases here. You can understand well, hope that it's fine. So next we move on to study about the change of states in the solid, liquid and gases. That we know that when we take the ice cube in outside, it will melt, right? and it changes into liquid. Again, this liquid we heated, it take part into the gaseous form. That we know. Again, this vapor we gain cooled, it take part to liquid. Again, this liquid we take part to the fridge, it taking again into the liquid means solid state. So this is the change of state that we studied. Okay, so let's move on to description. So actually you can see the picture here, the changes of state. Okay, so first of all, when a solid is heated, it changes into the liquid. You can see the picture. So when the liquid which is heated, it changes into the gas. You can show here, clear. So when the gas which is cooled down, it changes again into the liquid. It's actually the backup stage. Okay, so when the liquid is cooler, it changes again into the solid form. Clear. Example, I actually said that if an ice which is heated, it changes into water. If the water which is heated, it changes into the steam form. Okay, if the steam again cool, it changes into the water, and the water, if it's cooled down, it changes into ice. So this we call as the changes of matter or change of the states. How we change? Solid to liquid, liquid to gas when it's cooled down. Okay, so the change of states is we again classified by the melting, boiling, sublimation and effect of pressure on gas and at another point too. So first we move on to melting, otherwise it's called fusion. You can see the picture here. When the solid which is heated, the particles being vibrate with the greater speed and begin to move very freely. You can see the picture here, right? So then a particular temperature, the solid melt and it changes to the liquid form. Actually, this process we call as melting, which is also known as the fusion of particles here. Because from the solid, the particles is completely fused by the process. So that's why the name given as the fusion here. Clear? So the temperature of which the solid which melt, which is called as the melting point here. Okay, so the melting point of ice which is 0 degrees Celsius we call 273 Kelvin. Remember the point, the melting point of ice is 0 degrees Celsius and 273 Kelvin. It's very important. Okay, so next the point is latent heat of fusion. So actually what do you mean by the latent heat of fusion? You just look at the picture here. The amount of heat energy which is required to change the 1 kilogram of solid into the liquid at atmospheric pressure, which is called the melting, at the complete melting point, we call as the latent heat of fusion here. Okay, I will repeat one more. The amount of heat energy which is required to change 1 kilogram of solid into liquid at the particular temperature or the pressure, atmospheric pressure at its melting point, we call as the latent heat of fusion here. Clear? The next thing is the boiling. We know that you can see the picture here. When the liquid which is heated, it's a particle which is begin to move, which is very even faster. So then the particular temperature, the liquid begin to boil and changes into the gas, or we call as the vapor state. Okay. So the boiling is always called the bulk phenomenon. You can see the picture and the experiment. Also here, like boiling is a bulk phenomenon. Okay, so when the liquid boils at the bulk of liquid changes into its vapor state. Okay, so the temperature at which the liquid state boiling, it's called the boiling point. So the boiling point of water is 100 degrees Celsius or 373 Kelvin. Remember the point. Melting point of ice is 0 degrees Celsius at the 273 Kelvin. But the boiling point of ice is 100 degrees Celsius and 373 Kelvin. Keep the point into your mind. So, next one is the latent heat of vaporization. By the melting side, it's a latent heat of fusion. By the boiling side, it's a latent heat of vaporization. You have to remember the point. So, the amount of heat energy, which is required to change the 1 kilogram of the liquid into the gas to the atmospheric pressure at its boiling point, we call as the latent heat of vaporization. Remember one more thing, the amount of heat energy, which is required to change the 1 kilogram of liquid into its gas at its atmospheric pressure, we call as the boiling point. It called as the latent heat of vaporization. Clear? So the next thing is the sublimation. We know that the change which is state directly from the solid to gas or from the gas to solid. There is no intermediate change. So that's called as sublimation. That means directly solid to gas or liquid to gas. There is called as the sublimation procedure here. So if example is, if some solid camphor or some ammonium chloride which is heated, that changes into vapor. We know the change because the vapor which is cooled, it changes into the solid. You can see the picture here. Look at the picture deeply. We can see the solid camphor or the ammonium chloride which we heated deeply, it changes into the vapor. So the vapor which is cooled, if it changes into the solid. Okay, so next at another topic of the matter, which is the effect of pressure on the gases. We all see our LPG cylinder in our home, right? So we know the principle behind them. Okay, so when the pressure is applied on the gas, the particles which come closer and gases which is changes into the liquid form. Okay, so that's a principle here. So we can liquefy gases by applying pressure and reducing the temperature here. Okay, so you can see the picture here. Compressed solid carbon dioxide, which we call as the dry ice. By this study of about matter, we know that all these three states of matter which are interconvertible, that we feel and we studied by the earlier points, right? So actually, you can see the picture here. The changes of matter, you just keep on that arrow, focus on the arrow, okay? The changes of matter which is completely interconvertible. Look at the picture. Change of matter can be changed by changing the temperature or by means of the pressure. Look at here, the gas which is condensed to be the liquid, or by melting it turned to be the decomposition procedure, and again to gas, liquid, solid. It again back to by sublimation, freezing and evaporation. Once more, the state of matter which is interconvertible, by means of condensation it take part, by means of melting it take part decomposition, again back up sublimation, freezing, evaporation. These are the procedures which are interconvertible by means of the three states of matter. So next we move on to the evaporation procedure or evaporation topic. So change of liquid into the vapor at any temperature below its boiling point, we call as the evaporation. Look at the picture here. The evaporation, we know that the surface phenomenon. We studied about the bulk phenomenon earlier. So here the evaporation we call as the surface phenomenon. Okay. So particles from the surface gain enough energy to overcome the force of attraction and change it by the vapor state, that we call as the evaporation procedure here. Okay. So then we move on to what are the factors that are completely affecting the evaporation. Okay. So what are the factors? You just think, what are the factors? Yeah. So the rate of evaporation depends upon the surface area, temperature and humidity and of the wind speed. These are the key features which are completely affect the rate of evaporation procedure. Okay. So then increase the surface area, increase the rate of evaporation. Okay. Then increase the temperature by increasing the rate of evaporation. Increasing the humidity will by decreases the rate of evaporation. By increasing the wind speed, increases the rate of evaporation procedure. Okay. These are the key factors which are affecting the evaporation procedure. Okay, so the next thing, how the evaporation affect the cooling. Okay, it's the last topic here of the chapter, how the evaporation causes. When a liquid completely evaporates, the particles of the liquid which is completely absorb the heat from the surrounding and it's evaporated. Okay, so the surrounding become cold. So here the reason behind, when the liquid evaporates, the particles of liquid absorb the heat from the surrounding and it become evaporate. We can see and we know that the factor, that's so the surrounding become too cold. Okay, that we feel sometimes. Okay, sometimes. Okay. So example, people spring the water on roof or the open ground because during the evaporation, water absorb heat, make the whole surface become cool. Okay, so the during summer we sweat more because during the evaporation we sweat absorbs heat from our body and making it the body cool. So wearing the cotton clothes in summer keep us cool because the cotton absorbs the sweat, and when the sweat evaporates, our body it's absorbed sweat become evaporate and it heat up from the body making it body cool. Okay,